So welcome back, physicists and earth space scientists, continuing on with the level 1 NCEA standard 1.1, which is looking at the human effect on changes in the earth system. Today we're focusing on the first sphere, the atmosphere. So what is the atmosphere? It's basically a mix of gases that surround the Earth. So, for example, oxygen, which is about 21% of the atmosphere, and nitrogen, which is about 70%. Also, carbon dioxide and argon are major contributors. And essentially what it does is it protects us from the radiation from space, particularly from the sun, and also helps us control our temperature here on Earth. And the atmosphere can be broken down into 5 layers. We have the troposphere. That's where weather happens, okay, where climate occurs with the example clouds, hurricanes and storms. We have stratosphere, and that's home of the ozone layer, which made the news in the 90s as it was beginning to break down due to use of CFCs, but we've managed to do a reasonable job, but it's still quite weak in the poles, so that's why we get sunburnt so much here in Aotearoa, New Zealand. Then we have the mesosphere, and that's where the meteors burn up, okay, so it protects us in that way. The thermosphere, which is of course very hot, and that's where auroras happen, which is the interaction with the electrical field of the Earth, or the magnetic sphere of the Earth, magnetic field of the Earth with the electrical debris from the Sun in terms of solar spheres. And we have the exosphere, which is essentially the edge of space. So in terms of these changes in the atmosphere, which is what the standard is really about, the atmosphere changes due a number of natural cycles. Okay, so for example, volcanic eruptions like Mount Pinatubo in Indonesia, it released lots of sulfur dioxide gas and carbon dioxide gas, as well as a lot of dust, and that actually cooled down the climate because the sun's radiation couldn't get through, so that affected our climate. In terms of the sun's activity, I mentioned auroras in the previous slide around solar radiation. So that affects the temperature on Earth in terms of the greenhouse effect, and also the Earth's weather patterns. Then we have, as I just mentioned, the greenhouse effect, which keeps the Earth warm by trapping heat. So it's actually a natural process, but due to human climate change or human-induced climate change, that is changing as we get warmer and warmer temperatures globally. And then ocean currents and wind currents also help move heat around the planet. Okay, so in terms of the hydrosphere, it's ocean currents, but wind currents also move heat around the planet. So in terms of the interaction between the atmosphere and the other spheres, which is really the heart of the internal, what the atmosphere does is it transfers primarily the sun's heat energy and also matter, with the biosphere, the geosphere and the hydrosphere. An example of that, again, which will be really at the essence of the standard, is the carbon cycle. So examples of that are where the biosphere takes in carbon dioxide from the atmosphere, so for example through photosynthesis with plants. Then the biosphere releases that carbon dioxide by respiration, either through us humans or other animals. And also the hydrosphere absorbs carbon dioxide from the atmosphere, either by just directly dissolving into the ocean waters, also in terms of the seashells, for example, of the biosphere. Okay, and that affects the biosphere. So finally, why does this all matter? Well, the atmosphere affects both the climate, the weather and life on Earth because of that, because we live on Earth. The climate is of course important to us. We cannot live here if it's too hot or too dry, the Goldilocks zone, I guess you'd describe it. And human activities like the burning of fossil fuels and increased respiration are changing the atmosphere, okay, because there's more carbon dioxide in the atmosphere. So both science, which is the primary focus of this standard, but also in conjunction with Indigenous knowledge, we can better predict and respond to these changes. And that means that protecting the atmosphere means protecting your future and my future.